All right, we are going to go ahead and get started taking a look at our notes about classifying quadrilaterals. So this chart that you have in front of you, this is a really nice flow chart that kind of categorizes what a quadrilateral is. That's like our main topic. And then it's got all these subcategories that fall underneath a quadrilateral. So the prefix quad, anytime you see QUAD, if you hear people referring to like, oh, I was riding my quad this weekend, like a four-wheeler, quad, the prefix means four. All right, so a quadrilateral has four sides. So it's like the kind of like the umbrella term for any figure that has four sides is always a quadrilateral. And then another piece about a quadrilateral is that the sum of the angles is 360 degrees. So the sum of the interior angles is 360 degrees. Now, we learned the other day that the interior angles of a triangle add up to 180 degrees. So what I'm going to do is I'm going to take this quadrilateral and I'm going to break it into two triangles here. So you can see that I have my triangle that's in orange and my triangle here in purple. Well, the interior angles of my orange triangle add up to 180 degrees. The interior angles of my purple add up to 180 degrees. Well, when you put two triangles together, they create a quadrilateral. And if we add 180 plus 180, we get 360 degrees. So anytime we see a quadrilateral, a four-sided figure, we know that all of the angles, so if you were to add up angle 1, angle 2, angle 3, and angle 4, they should add up to 360 degrees. So that word quadrilateral, that's kind of like a blanket umbrella term that all of these other shapes fit into. All right, so one specific type of quadrilateral is called a trapezoid. And a trapezoid, the main definition for a trapezoid, obviously it has to have four sides and the sum of the interior angles is 360. It has to meet everything that a quadrilateral has, but it also has to have one pair of parallel sides. So it has to meet all the requirements of a quadrilateral, and then on top of that, it's got to have a pair of parallel sides. So in this diagram, I can easily tell that this line here at the bottom is parallel to this line here at the top. And it doesn't necessarily have to be that one's at the top and one's at the bottom. All right, a trapezoid could technically be turned sideways like this, and you could have these two kind of slanted sides that are not necessarily parallel, but then we can see that I have the left and the right side here that are parallel to each other. So that's what makes this a trapezoid. Now, underneath the category of a trapezoid, we have something called an isosceles trapezoid. And an isosceles trapezoid has to meet all the requirements of a trapezoid, all the requirements of a quadrilateral, and on top of that, it has to have the non-parallel sides. So the non-parallel sides are congruent. Congruent means that they are equal to each other. So just like a trapezoid, we have to have one pair of parallel sides. So I can see, I'm going to use these arrows here to indicate that these are my two parallel sides. So that's what makes it a trapezoid. But now the word isosceles, just like an isosceles triangle has two congruent sides, an isosceles trapezoid also has to have two congruent sides. So these two sides that are not parallel to each other, that are like those slanty sides there, they must be congruent to each other in order to be a specific type of trapezoid called an isosceles trapezoid. So we could say that an isosceles trapezoid is a type of trapezoid and it's a type of quadrilateral, all right? But that does not mean that all quadrilaterals have to be trapezoids, all right? It doesn't really work like that vice versa way. we can say all trapezoids are quadrilaterals, but we cannot say that all quadrilaterals are trapezoids because we've got this other side of our flow chart here leading us to another type of quadrilateral called a parallelogram. And with a parallelogram, we have to have opposite sides parallel. So with a parallelogram, we have to have two pair of parallel sides. All of the opposite sides have to be parallel. With a trapezoid, you only have to have one pair of parallel sides. With a parallelogram, you have to have two pairs of parallel sides. So I could draw arrows on these two sides here, showing that they are parallel. And because this is a parallelogram, it has to have two pairs of parallel sides. So on my second set, I'm going to put two arrows to indicate that those are the two that are parallel. So opposite sides are parallel to each other. And because those opposite sides are parallel, those opposite sides are also congruent, meaning they are also equal to each other. Now, a parallelogram has two different subcategories, right? So a parallelogram can get more specific and become a rhombus. So with a rhombus, it has to meet all the requirements of a parallelogram. It has to meet all the requirements of a quadrilateral. But with a rhombus, all sides are congruent. And I'm going to use my congruency symbol here. So with a rhombus, we still need those opposite sides to be parallel. So I'm going to use my parallel symbol here that we learned about the other day. But on top of the fact that all sides are parallel, they also all have to be congruent to each other. So with a rhombus, all four sides are congruent to each other and opposite sides are parallel. So I will draw my arrows here indicating my two pair of parallel sides. Now, a parallelogram could also be classified or become more specific and become a rectangle. So with a rectangle, again, it has to meet all the requirements of a parallelogram, it has to meet all the requirements of a quadrilateral, but with a rectangle, all angles are 90 degrees. So a rectangle is required to have 90-degree angles here. So all those angles are 90 degrees. And then just like a parallelogram, those opposite sides are congruent and parallel. So I could say that these two short sides here are congruent to each other and are parallel. And then these two long sides here are congruent to each other and they are parallel. And last but not least, we also have a square. And you can see that a square kind of like bridges together all three of these. So a square is a special type of rhombus. A square is a special type of rectangle. A square is a special type of parallelogram. And a square is also a special type of quadrilateral. So a square meets everything on this right side of the flowchart. It meets all of the requirements. So a square is going to have, just like a rhombus, it's going to have all sides congruent. So it meets that category of a rhombus, that all sides are congruent. Opposite sides are parallel, just like a rhombus and a rectangle. So opposite sides are parallel and congruent. Opposite sides are parallel and congruent for a square. And then a square The reason that a square is different than a rhombus, so a square and a rhombus are almost exactly the same as one another. The only difference between the two of them is that a square has to have 90-degree angles. So the only difference between a square and a rhombus is that your square is going to have 90-degree angles, a rhombus does not. So because of that, a square is a rhombus, but a rhombus is not a square. It doesn't go backwards up, like you can't go backwards up this flow chart. And so I'm going to go ahead and I'm going to put my congruency marks here that show that a square has 4 congruent sides, just like a rhombus. And those 4 congruent sides, that's the difference between a square and a rectangle. All right, so a square has 4 congruent sides. A rectangle has 2 pairs of congruent sides. So we can say that a square is a rectangle, but we cannot say that a rectangle is a square. All right, remember we can go down through that flow chart, but then we can't go back up it.